Yeah.
So, we're going to do some some multiplications to start with. So we've got 428 times by 16. Four two eight times by 16. That's our sum. That's what we're going to look at. So, when I was at school, when I learnt this, and this is the first way I'm going to show you. I'm going to show a couple more ways in a second. Well, this is the way that I learnt when I was at school. I thought to myself, or I was told that that 16 there is made up of a 10 and a 6. That's what makes 16 up. So I'm going to multiply this number by 10 and I'm going to multiply that number by 6 and then add the two numbers together. So you set it up like this. There's your 428. You're going to times it by 16. So we remember that these are our hundreds, those are our tens and those are our ones. So we can see we've got 428, we're going to multiply it by 16. Now, again, the way that I learned this is whenever you multiply a number by 10, you just put a naught on the end of it. So it works. So in this instance, because I'm starting in this column here, in the tens column, I'm going to put a 0 in the ones column because I'm not using that. I'm using this column here. Can you see how that works? I'm using the tens column. So now I'm just going to do this. 1 times 8 is 8. 1 times 2 is 2. And 1 times 4 is 4. Obviously everything's moved along a step, purely and simply because we put that 0 there. But look what we've done. There's 428. When you times anything by 10, you just put a naught on the end of it. So it's 4280, 4,280. So we've timesed it by 10. That's that times by 10. So now we're going to times it by 6, which is this column here. So we're starting in the ones column. 6 eights.
48.
Hey, someone's been practicing times tables. 6 twos. 12 plus 4.
16.
6 down, a little 1 to carry. 6 fours, 24, and 1 makes 25. 25. So that one there is that number times by 6. What we do is just add them together. Nothing plus 8 is 8. 8 plus 6 is 14, with 1 to carry. 2 plus 5 is 7, plus 1 is 8. And 4 plus 2 is 6. And we get the answer is 6848. Okay? Long multiplication. That's the way I learned to do that in school. It's not for everybody. Some people love that method, some people hate that method. I grew up with that method, I'm quite okay with it. And I'm not, it doesn't faze me, it doesn't frighten me to do it that way, I will do it that way. But it's not my favourite way, okay? I'll show you my favourite way, not this one. Let's get some cloth to light this up in a second. Can you follow that? Does it make sense?
Yeah, in school we teach it that we do the ones column
First,
and then the
yeah.
tens.
It's just
It's
that.
the same thing, isn't it?
It's the same. Yeah. You can do them either way around. It's up to you. It's just that I started by working my way towards the ones column rather than away from it. But yeah, they would just be the other way around. That's all. Yeah, that's fine. So that was the way I learned in school. Done it that way for many years. But then, when I started to teach maths, I come across a new method. It's not new, it was new to me. It was called the lattice method.
I think I know what you mean. I like that method.
Do you like it?
The box one,
Yeah,
put it in boxes.
Oh, I love it.
I like that one.
I love it. Don't tell that original method, it'll get jealous, but I do. And you'll either get this or you won't, because it's one of them. So what you do, there's your sum, 428 times 16. 4, 2, 8, little tiny times sign. And then this is strange, because you write 16 down there like so. Ooh, that looks a bit crazy. And what you do, you draw yourself a box like this. Now because you've got 3 numbers across the top, you split your box in 3. Because you've got 2 numbers down the side, you split your box in 2. And that doesn't matter for how many numbers you had. If you had 5 numbers across here, you'd split it into 5. If you had 4 numbers down there, you'd split it into 4. Then what you do, you divide each of these boxes diagonally. And I always put a nice little tail on the end like that. Don't ask me why, but I always put a nice little tail on. You've got to be pretty accurate when you're drawing these boxes. But you just split every one of these little boxes in half. Yeah? So it looks like that. It takes you longer to draw the box than it does to actually do the sum. A close-up of one of those boxes would be looking like this. In the top of the box there go your 10s. In the opposite side of the diagonal go your 1s. Okay, 10s and 1s. So how does that work? Well, what we do, we pick this first box here. And you can see that that first box is 8 times 1. 8 times 1. 8 ones are 8. That's no 10s, 8 ones. So then we do this box here, which is 8 times 6. 6 8s or 8 6s are 48. That's a 4 there and an 8 there. 2 1s are 2. No 10s, 2 1s. 2 6s, that gives us 12. 12's made up of 1 10 and 2 1s. 4 1s are 4 and 4 6s are 24. There we go. So we've now completed our little box. So now what we do, and this is the thing you've got to remember, this is the important part of working with these. And if I've got a red pen, I'll do it in red just to show you that it is important. Oh, I'm not going to do the sum in it. Aye. You start adding up now from here. Okay? You start adding up from the bottom right hand corner. And what I do to try and get people to remember to do that is this. I cover the rest of the sum up. And you can see that just in that diagonal there is the number 8. So that's your first number, 8. We then slide this across and we add these together. We now come down this one. 8 plus 4 plus 2 is 14. 4 down. Your 1 to carry comes this way because you're moving your paper this way. And it kind of goes there. 2, 3, 7, 8. 4 plus 2 is 6. And that's a 0. 6, 8, 4, 8. That's what we just got before. Amazing. You'd think I knew what I would do. The lattice method. I find it so much easier than that long multiplication stuff.
I find that confusing.
You find that
right,
confusing?
yeah.
I like that way.
Yeah?
I prefer the other way of thinking.
It's like Marmite.
Yeah,
You'll
yeah.
either love it
Yeah.
or hate it. Yeah? You'll either love it or hate it. I've had people that have started with this. Paul, who was in the other group, Paul used to be like you, he liked the old longs, and we were really struggling to get to grips with it one time. So we did this. And he fell in love with this and thought, I'm just going to use that method all the time. Just going to use it all the time. I like that method. Takes a bit of setting up, takes a little bit of getting used to, but it's important, remember, when you start to add up, that you start to add up from this bottom right hand corner and work your way across. And cover it up. That's an 8. Yeah? You get a chance to practice some more of these, don't you worry. So, one more way that we can use this or do some adding up. I've got a graphic to show you this one. Well, that's the lattice method. Is to use what's called a ratio table. Okay? 24 times by 35. So we set it up like and it's all about making things into one part, what one part is worth. Well, one part is worth 35, and we're going to times that by 24. Okay? So basically what we do, let's hope this works, I put this together yesterday. If we times 1 by 10, we get 10. So if we times 35 by 10, got to do the same thing, we get 350. If we times 10 by 2, we've then got 20. So if we times the 350 by 2, we've got 700. So, are you with me so far? Yeah? I've times that by 10, and I've doubled it. So I've times that by 10, and I've doubled it. So in effect, what I've done now, I've times that by 20. Okay? I've times 35 there by 20. So then what I'm going to do, I'm going to just add 1. Which gives me 21. So I'm just going to add 35 to that, which is going to give me 735. Follow? Because that's one part. One part. Yeah? Times 1 part by 10, you've got 10 parts. That's 35 parts. If I times 35 parts by 10, I've got 350 parts. If I double that, if I double my 10 parts, I've got 20 parts. So if I double my 350 parts, I've got 700 parts. Yeah? So then if I add one more part to that, I've got 21. If I add one more part, which is 35, remember, I've now got 735. It's making sense. It's kind of making sense to you now. Yeah? So if I add another one, I've now got 22. So I add another 35 to the bottom, which gives me 770. If I add another part, I've now got 23. So I'm going to add another 35 to the bottom, which gives me 805. And finally, if I add another one, I've got 24. So I've gone from 1 to 24. So now I'm going to go from 35 to 840. I've times it by 10. I've doubled it. So in effect I've times it by 20. And then I've added 4 more to it. Remember when we did the 16, we times it by 10, then we times it by 6. Well, in this case, we've times it by 10, we've times it by 2, which gives you 20, and then we've added 4, 24. Yeah? So we've took that 35 and we've times it 24 times. 10, 20, 1, 2, 3, 4. Double it. Times it by 10, just stick a naught on the end. Double it, that's what we did there. Add one portion, add another portion, add another portion, add another portion. Does it make sense?
If it was over times 5, would you subtract instead of adding more?
If it was what?
Over 5, if you was rounding it up, would you subtract instead of adding more?
If we were rounding up, rounding what? What do you mean rounding up?
So say it was like 24 times 38, would you round it up to 40 and then subtract?
No, I'd still do it to 38, to be honest. I'd maybe do it slightly different way. I'd do it to 35 and then add 3 extra. Have I got another? Oh, I've got another method to show you on this next slide. This might make it slightly easier to understand. These take a bit of practice, to be perfectly honest. Same sum, 24 times 35. So we'll start off the same, we'll times it by 10, gives us 10. So 1 times 10 is 10. Whatever you do to the top of the sum, you do to the bottom of the sum. So times the 35 by 10 to give me 350. Double it, there's 20. Double this one, gives me 700. Okay, so we times 35 there by 20, by 10, and then we've doubled it, so we've times it by 20. But now what you do is you take the 1 and you times it by 4. It gives you 4. 1 times 4 is 4. So now across the top what we've done there, we've times the 1 by 24. So we need to now times the 35 by 24. We've times it by 10, we've doubled it, which means we've times it by 20, So we just need to times the 35 now by 4, and in a minute we should get a big arrow that does this. There it is, times by 4. 35 times by 4, 40. 20 plus 4 is 24. 700 plus 104 is 840. Same sum, just done slightly different. It's a bit more confusing, that, I think, than the lattice method. But some people like to use that kind of method. Me, I don't think I'd bother to do that. But you could use it. You could, whatever you feel most comfortable using. I don't, to be honest. I've got my head around it, but it looks too much for me. Looks too much. I prefer to just do the last month. But I thought I'd show you just in case you fancied having a go at it at some point. You might not. I don't think so.
I think if you're in an exam, you're not going to do that, are you?
No.
Because it takes too long.
To be honest, you know, practice it. Just have a go at it at some point, and if you think, nah, just chuck it, don't bother with it. Because it can confuse you a little bit. We'll come back to that when we start doing ratios, to be honest, because that's basically all it is. That's one part, that's 35 parts. That's all you're doing, basically. So, now it's your turn. There you go. Oh, we've not done division. We've not done division. Let's come back. I've got no division slides on there because I'm just going to show it on here. Sorry, my apologies there. So I'm just going to whiz back a couple of slides. No, I'm not, because I can remember the sum. So you'll be okay there with one of those multiplication methods. Pick one, yeah? Pick one that you would like to use when you get to do the sum in a second. Now there is no slide for long division because purely and simply there's one way and there's one way only. And I'm going to show it you. You could probably use that kind of method, but I'm not going down that road. Right, here we go. Everybody's favourite. Long division. Everybody loves this. Here we go. We've got 64,320 and we're going to divide it by 12. Okay, it's all about finding what one part is worth. So we're going to divide that by 12. So this is how you set it up, and you'll know this because you'll have seen it. You'll have seen it loads of times. It's the bus stop method. 64,320 divided by 12. Now then, it's going to come up in the non-calculator part of the exam and you're going to be panicking because it's all about the 12 times table. You don't know your 12 times table. I've given you 12 times table, but you've not memorised it. You're struggling. So what do? You don't panic. You draw the 12 times table down the side of your page. You just write it down. You can do this. It's going to be your exam paper. You can do what the hell you want on your exam paper as long as you get the correct answers. So there's the 12 times table down the side of the page. Doesn't matter what you're dividing into that. Just do that times table. So now what we're going to do is going to start, and you work from this side across. How many 12s go into 6? No, doesn't happen. Yeah? Now you could put a 0 there if you wanted to. I don't particularly like doing that, to be perfectly honest, so I just ignore it. So 12 won't go into 6. So your next full number then is 64. Just ignore those for a second. How many 12s go into 64? So you look at your 12 times table. 2, 3, 4, 5, 60. Can't be 6 because that would give us 72. So it's 5. So the 5 goes there. Okay, because 12 has gone into 64 5 times. What I like to do at this point is to say 5 12s is 60. So I write 60 here. You don't have to do this, but this is just the way I do it. It's what I learned. I'll show you a different sort of way of doing it in a second. We needed 64, we only got 60. So the difference there is 4. 64 minus 60 gives us a difference of 4. Now these two numbers now have been used. you've used those numbers, you could cross them out if you wanted to. Pretend they weren't there. If that was the case, then that 4 would be up here. So now you've got 12s into 4. Well, that's not going to go, is it? So the next number in the sequence is this 3. Remember, we've used these two numbers. So the next number is this 3. So I bring the 3 down here and I just pop it next door to the 4. So now I've got 12s into 43. So again, back to my times table. And I can see that it goes in 3 times. And that's 36. Can't be 4 times, because 4 times 48 is a lot more. So it's 36. So I put 36 down there and I draw myself a little line underneath and I do the subtraction again. 43, take away 36, gives me 7. 7 remainder. There it is. So now I do 12 into 7. Well, that's not going to go, is it? Certainly isn't. So the next number in my sequence, the one I've not used yet, is this 2. So I bring this down and I pop it next to the 7. 12's into 72 I've got now. 1, 2, 3, 4, 5. There we go. Bang on 6 times. Exactly 6 times. Which means I've got nothing left over. However, I've got a number here that I've not used. I can't just leave it lying about. So what I have to do with it, I have to pop it on the top. So it goes there. So 64320 divided by 12 is 5360. Now that's how I learned to do this when I was at school. There's only one way of doing division, and this is the way that you do it. How you set it out, how you actually carry out the calculations, entirely up to yourself. I like doing that. It's the way I've grown up with. But you don't have to. You can do this. 12s into 6, got to do the same formula, the same method. 12s into 6 doesn't go. 12s into 64 go 5 times, we already decided that, which is 60. What have you got left over? 4 left over. You can put the 4 there. Yeah? So if I was to get a green pen and put some imaginary lines down, yeah, there you go, you can see. 12s into 6 doesn't go, 12s into 64 goes 5 times. I have 4 left over, so I drop the 4 down into the next column. That now makes 43. 12s into 43, we've decided that that's 3. We have 7 left over, so we drop the 7 into the next column. 12s into 72, 6 times, we decided that. Nothing left over, so you've got to put that back on the top. It's a bit quicker, it's a bit less writing down here. I don't particularly like it, purely and simply because when I'm doing a division, when I'm thinking about division, I'm thinking about making something smaller. To me, what's happening is that number, it's gone from being 64320 to being 6443720. The number itself has started to look bigger. It's not bigger, but it's started to look bigger. When I did it this way, I just had 2 numbers all the time. I had 2-digit numbers all the time. Whereas that number there, it's looking bigger. It's just visually looking bigger. Both ways work. It's up to you which one you decide you want to do. Unfortunately, that's the only way to do long division, by setting up the bus stop and working your way from left to right. See how many times that goes into that. If it doesn't go into that, then you've got to use the next number, carrying over the remainder, and so on and so forth. These are the ones that everybody hates. Division. Nobody likes them. I've not met a single person who likes them at all. Fancy having a go at a few? No, Glynis. Let's have a go at a few. Let's have a go at a few. Let's pop some up here. There we go. So you've got some. Quite a few to do there. Long multiplication, long division. Tell you what we'll do. Let's just do 3 of each. Pick any 3 long multiplications, pick any 3 long divisions, and just do 3 of each, just to see Any three you want, where it's up to you, and use the method that you want. I'm guessing nobody's going to use the ratio box method, but pick the method that you want to use, that you think you're going to use, that's going to be the best for you. And we'll see if we've mastered it. If you're not sure, try two of the methods. I'll flirt round and have a look at what you're doing. While you're doing that, I'll just tell you a little story.